Greetings and welcome, internet friends. Mr. Waddy here and his G amigos. We're talking about correspond minus ing parts. Some people thought this looked like it said Paris, bless you. But that says parts, and we're talking about corresponding parts of congruent figures today. So corresponding parts are objects that have the same size, shape, place, two figures. Bam, I said that so good, I'm teaching. So here I've got a claim. Notice this. This is actually going to be a lot of notation. Remember back in the day when we were naming angles? We were naming angles, and we had to name angles specifically in an order in which the middle letter was the vertex of the angle. You guys all remember that? Mr. Waddy's internet friends, just so you're aware, Mr. Waddy's students all nodded and said, yes, Mr. Waddy. Triangle ABC is congruent to triangle DEF. The order of these letters matters. Now, there's technically 6 different ways we could have written that, Yoshi. Come sit down and stop doing that. But once I've picked an order, the order of the other name has to match it. It has to match it by giving me the corresponding parts. So, what this means is that angle A, we'll do sides first, tell you what. Side AB, let's go with. Who is side AB congruent? DE, well done, well done. So that is congruent to DE. And one of the ways you can tell that is that the order of the name A, B, and DE are both the first and second letter in that name. All right, so we're going to be familiarizing both with the sketch and with the name convention. All right, how about BC? Who's BC congruent to? EF. Yep, those are the short sides of each of their respective triangles. And notice, even if I didn't have a sketch, BC and EF are the last 2 letters of each of those names. And so those 2 segments must be congruent. Now, what is the third side length that needs to be congruent to triangles? AC and DF in unison. Wow, this is awesome. All right, AC is congruent to DF. And wait a minute. Notice in the names here, it's like AC was the first and the last, and D and F were the first and the last. That still done works. Because if I'm looking at the triangle, I can keep going around and around and around. And so same thing with this name, when I went this way, it's like it looped back around to the beginning. So the C to the A had to be the other one, the F to the D had to be the other one there. So those are all the corresponding parts of these triangles that would be congruent if the 2 triangles are congruent. Make sure you're writing this down because you have this as a resource later. Yeah. How about for angles? For angles, angle A is congruent to who now? That's correct. Angle A is congruent to angle D. And notice in the naming convention, A and D are in corresponding positions. So the name matches the figure. Good stuff, good stuff. Let's see. And how about angle B? Going to be congruent to angle E, yeah. So I'm going to mark that with double arcs in my drawing. And in the back, make sure you're writing this down because I don't have a video for this yet. No, it's in the foldables. Here, Yoshi, you can put those away forever, thanks. Let's see. And last angles would be angle C. Maybe that's a right angle. And angle F. So angle C is congruent to angle F. And so all of the corresponding parts are congruent to their corresponding parts if the original 2 figures are congruent. Now, actually, let's say I had a different name for the first triangle. If I said triangle BAC, what version of the DEF triangle would be congruent to BAC? EDF. Yeah. F, right. So, yeah, so I just have to go around the triangle in the same exact fashion. so that the corresponding angles and the corresponding sides all line up. Right? Right? Right. So, here's an example. And notice this example, first of all, like glancing over the whole thing. I've got segment BC is talked about here, and later I have DF without the segment hat on it. So DF without its hat is referring to the length of segment DF, and notice it's using equality because the length is represented with a number. And the same idea here, these are angles, the objects, and this is a measure of an angle, which is a number. So for this, let's do this. BC, who's BC congruent to? Yeah, BC and EF are in corresponding positions there. Oh, right here. So it looks like EF. Transformation, friends, from chapter 4, it looks like what sort of transformation happened between those two figures? A rotation of 270 degrees or negative 90, depending on how you think about it. Yeah, it looks like this got rotated negative 90 degrees. All right, how about angle F? Angle F right here. Who's angle F congruent? Yeah, angle C. Yep. So angle F, angle C, right there. And this is talking about the angles themselves, so that's why congruence is being used, and I'm not talking about the measure of. All right, how about measure angle A? Yeah, that's going to correspond to D. And notice that A and D are in the same position with respect to their names. And also, I mean, technically, once I see the relationship between the two, maybe you could have imagined this having been rotated like so, and then it's like kind of match a little bit easier, right? Get that out of there. All right, so now we're swapping, not in reference to the angle, but in terms of its measure, the measure of angle E. Yeah, that's going to be 77. So actually, I'm going to write two things here. We can write measure angle B, and that's also equal to 77. Both of those things are true. I'm pretty sure, like, on the homework tonight, they'll be looking for just the number. But I wanted to point out, technically, it's both of those. For DF, the B and E matched up. B and E were both the middle initial of those triangle names. Right? So DF was this one right here, and DF corresponded to AC. D and F were the first and last. A and C were the first and last. So it would equal AC, which is equal to 5, right, by substitution or transitive. Centimeter. Oh, here we go. Triangle. Actually, I'm not a fan of their triangle symbol there. What's the name of the triangle if ACB is the order? I think it's DFE. Because D matched with A, C is the next one, and C and F matched. All right, it takes a little while to get used to that. And so as far as naming conventions go, when we're doing a proof later, we might all have come up with a slightly different name for the triangle, but once you pick one name, you are locked in for the other one's name. Right? Hey, here we go. So, we have talked about congruence before. Two figures are congruent if they have exactly the same size and shape, right? Same size and shape. What was true about figures that were similar? Talk about similarity before. They were not. They didn't have one of those. But what did they have? They were the same what? same shape but different sizes was when we would have a dilation between two figures. Don't worry, you can still write this down. Right, same shape but different sizes. Congruent has both same size and shape. Grab a pen. So here's another way to think about congruence. Two figures are congruent if their corresponding sides and corresponding angles are congruent. All right? If every piece of the figures match up, then the figures themselves are congruent. And actually, I was telling this to Block 2. Today's lesson is going to be the frustrating lesson where it's like, imagine an infomercial where it's like, have you ever had a problem storing bread in a cabinet? And then there's some lady like, ah, blah, blah, and then like the bread falls all over them and the bags, like for some reason she makes them explode, right? That's what this lesson is going to be, in which I'm having you like, well, man, there's got to be a better way to prove two figures are congruent. We're like, right now, sadly, the only way to prove congruence is to say every corresponding part is congruent, right? Every corresponding angle is congruent to the other corresponding angles. And the majority of the rest of this chapter will be focused on triangles specifically and saying, what is the least amount of information I need to prove two triangles are congruent? Do I really need to say all three sides and all three angles before I can, with confidence, determine whether or not those figures are congruent? And so today I realize it's a little bit frustrating because I literally have to kind of almost say every literal part to prove congruence. But here we go. Let's take a look at example 2. Yeah, I hope someone takes the audio from this clip and makes an animation of it with my face somehow as the person trying to put bread in a cabinet. Oh no, it's showed up on a handful of Wadimath videos. I don't put my, okay, internet friends, student, local person, mathematician, is asking why my face isn't in more of these videos. And you know what? I know the channel's called Wadimath, but honestly, it should be called Math Wadi. Because this channel is more about the math than it is about me. It's the math is front and center, is the thing being celebrated here. Who am I? I am one of billions of humans that have done math in the history of the world. The math is the thing that we're celebrating here today. So anyways, I have looks like trapezoid apogee is congruent to trapezoid apogee. Yes, question, comment? Yeah, I kind of saw that, but I. I'm not changing. There's a color theme that I was doing with sides and angles that I'm gonna try to stick with, but I'll do some yellow in a moment. Don't you worry. Internet friends, feel free to make some requests in the comments below of your favorite Wadimath colors. So okay, here we go. Angle F. Who's angle F congruent to? F corresponds to B. Right here, right? So if angles F and B are congruent, then by def of Kong and substitution, I could say 7x minus 9 is equal to hundo 10. So to solve, I would add 9 to both sides. Oh dear, I've got to do math. Whew. The algebra. All right, reaching for that calculadora, right? Let's see. So x, this does go in evenly. I just don't remember the answer. But the calculator does. The answer is 17. So I just found x. Now for... Oh, guys, I just mixed up my color pattern. That's weird. The angles are supposed to be purple. The sides are supposed to be... Oh, how embarrassing. So, who is FG congruent to? FG is congruent to BC, right? So if those two things are congruent, by def of Kong, their measures or their lengths are equal, and by substitution, I could write 3y minus 12 equals 6. Question, comment, observation? Purple. Let's see, 3y equals 18, and then you algebraify this right here like so. So I get y equals 6. Nice. So the idea is I have to relate corresponding parts to corresponding parts. So, all right. Am I good to go to the next one? Oh, we got another theorem coming. I'm so excited. All right. Third angles theorem. We will call at third angles theorem. So, here we go. You guys are going to get this one. This is going to be so good. All right. So, if angle 1 is congruent to angle 4 in two triangles, and angle 2 is congruent to angle 5, then what is true? No, I don't have a transitivity train. Angle 3 is congruent to angle 6. Well done, sir. So angle 3 is congruent to angle 6. Now, eventually we'll do a formal proof of this, but does anyone know why that would have to be the case? If I know that the first two angles of two triangles are congruent, why would the third angles have to be? Yeah, you're on the right track. They're the only ones remaining, kinda. Now, what do I know that all three of these angles add up to? 180. And so if I already have these two as fixed values, the third one can only be a particular thing. It's going to be whatever 180 minus those two is. And the same thing for over here. This one is going to equal whatever 180 minus these two is. And so these two things are set. There's only one possible number that would add to the other two that would equal hundo ate. Ote. Yeah. So here we go. I've been told that these two triangles are congruent. So, by third angles theorem, here we go. This angle and this angle must be congruent. So this was also 42 degrees. And also, this angle and this angle must be congruent. What's this one gonna be? Y, yeah. So I know that all of their corresponding parts match up. The third angles are all going to be congruent to one another. Let's see if I can write an equation in terms of the x's. So angle E is congruent to angle B. I like how. So 8x minus 1 equals the 87. And 1. Make sure you're writing this down because you want this as a resource. And you're 7 times as likely to remember something if you write it down. I don't know about that. If you say that fact over and over for 20 hours, will it be stuck in my brain? No one. So let's see. How could I solve for y? You guys have a strategy to find y? Yeah, all three of these angles got to add up to hundo ate. So 3y plus the 42 plus the 87. What do we call that theorem, by the way? Trisum. That's right. Trisum. So 3y plus hundo 29 ate minus the 120. All right. It's going to be so good, guys. All right. Ooh, 51. And oh, that is divisible. Yeah, I think it's... say that it's 17. Leave it. So I can find the value of y. So yeah, you can, corresponding parts are congruent. Third angles theorem. If you got two triangles and their first two angles are congruent, then their third angles are also congruent. So good. All right, so we're going to jump into the world of the big ideas. So open up your big ideas packet and find example 2. This is when I would have like some music montage of someone saying, "Hey, what's the big idea?" As like we transition to the big ideas portion of our video. What's the big idea? All right. Yeah, you like that? There you go. So, all right. So guys, don't be scared of this, but def g and specure, they're congruent. So let's see what I can do here. So if I want to find, where's the x? Here's x. So QR is right here. Who is QR congruent to? GF, right? QR are the last two letters here, and FG are the last two letters there. Yeah, those are congruent. So I could then say 2x minus 4 equals 12. Right? Tell you what, let's set up the other equation while we're at it. If I want to find y, angle Q is congruent to who? Q and F. Yeah, second to last letter in the name. So Q is to F. Right? So I could say 6y plus x is equal to 8. And notice, right, if you want to use your transformation skills and imagine a world got flipped, turned upside down, right? You could like kind of, maybe you could match make those things a little bit better, or maybe that's just horrifyingly monstrific. I'm good. So, but yeah, it looks like it was a hundo 80-degree rotation. So let's solve. Bless you. All right. This is like a montage where we do a whole bunch of algebra together, and then we're strong at algebra by the end. So, to find the y, notice I could plug in the value of the 8 that I found with x. Plug it in. So, let's keep solving. Subtract ocho both sides. Div 6, and I get y is equal to 10. And just be careful, make sure that they're actually asking you to find for the value x and y, because x and y is all they're asking for, and not that they're trying to find the measure of an angle, for instance, right? Yeah? You goodsos? You goodsies? Do we get to do example 3? I don't remember. Here we go, here we go. Example 3. Oh, guys, have you ever painted a room and then you're like, oh, trapezoids? So guys, here's the problem. In order to show that those two trapezoids are congruent, I have to show that all 4 sides are congruent and all 4 angles are congruent. This is going to be so much work. This is a trapezoid. It's got 1 pair of parallel sides. Yep. So, here we go. Let's label what we do know, and I'm going to color coordinate it like so. So I know that AJ is congruent to KC. Yeah? No. Big ideas packet. Track with us. Track with us. I know that Donkey Kong is congruent to who now? Who's Diddy Kong? That's right. JB. Nope. JB. And I know that AD is congruent. Student just said Justin Bieber, and oh, there you go. Is congruent to BC. So guys, How? That's only 3 of the sides of these trapezoids. Zoidberg. I've got to figure out JK to JK. How can I show that JK is congruent to JK? Almost. That's actually super... Yeah, wow, guys, that was record timing. JK is congruent to itself by the reflexive property. Wow. That can happen. Reflexive. Anything is congruent to itself. And JK is a common side shared between both figures, and I can say it's congruent to itself. So guys, good news. I've got all 4 sides congruent, but I still got to do angles. So here we go. Oh, it is kind of like you're saying how the figure looks like a rotation. Student said, couldn't it be rotative property instead of reflexive? I found that pretty amusing. But reflexive was when something is congruent to itself. Symmetric was when if A equals B, then B equals A. All right, transitive, you're all big fans. All right, so let's say let's keep cranking out some angles now. Angle A, who's angle A congruent to? Yeah, technically it is congruent to D and B and C, but I'm going to think about the world of corresponding parts, and I'm going to say A is congruent to Charlie. And I know that those are congruent by right angles congruence theorem. And then I also happen to know that angle B is congruent to angle delta. Right, those ones are congruent. Good stuff. Also by right angles congruent. How can I find those other angles? Now, oh, check this out now. Funk is your brother. Look at this. This and this, I think I could prove these are parallel. Do you guys think those are parallel? And not just because of construction that's well done? Oh, because of those 90-degree angles. Look at that. We call that the lil patat. Right? Remember that? Lines perpendicular to a transversal theorem. Lil patat. Those lines are parallel. And they are plural. Yeah. And now, how could I attack these 4 angles? And it's related to parallelity. Here, you should write this down. This is gold. Angle 1. Who's angle 1 congruent to? And what kind of angles are those with respect to those parallel lines? Interior? Alternate interior angles theorem. Come on, friends. We're doing this. Those angles are congruent once I know the lines are parallel. And similarly, angle 2 is congruent to angle 3 by alternate interior angles theorem. All right, so guys, all of that work to finally say that A, D, K, J is congruent to, let's see, I started at A, and so that means I have to start with C. C, okay. And then I went to D, and D corresponded to B, so B is the next one. So C, B, J, K. Don't worry, we're good. So I can finally say that these 2 trapezoids are congruent to each other because, here we go, corresponding parts of congruent figs are congruent. I think I just did. I did abbreviate it. Actually, in the future, we'll be practicing in 5.7 CPCTC, which says corresponding parts of congruent triangles are congruent. So we could call this CPCFC? You guess. But guys, the rest of this course, or chapter rather, we're going to be trying to figure out there's got to be a better way than showing all of the corresponding parts are congruent. There's gotta be a better way. All right, so let's take a look. Oh, I've got 2 more problems I want to do. Yikes. I don't want them to find me in the real world, though. So, guys, check this out. Sometimes it's helpful to break up overlapping triangles to then be able to visualize what's going on a little bit better. So notice this. If I redraw these triangles kind of like that, then I can see, okay, this is 45, this is 45, the 30-degree angle is this one, and what's the 30-degree angle over here? Yeah, the little C one right there. Because notice there's actually a big C, and then there's a little c corresponding to right there. So find the measure of B to the D to the C. Ah, that's the big one right there. How could I find this angle? Yeah. Try some theorem. So measure angle BDC plus 30 plus 45 equals 180. So measure angle BD plus 75. Subtract hundo one Subtract 75 from both sides. Come on, gentlemen. And I get measure angle BDC is 105. So, and actually, guys, I bet you could tell me what angle ACD is. What's the measure of angle ACD gotta be? The same, by the third angles theorem, right? They all done gotta be congruent to one another. If I already got 2 angles congruent between 2 triangles, the third angles are also congruent. Good stuff, good stuff. All right. Proving. All right. Well, I don't know. You guys were giggling. I thought you were done. I thought you were giggling because you're like, I did this problem so fast. Yep. Nice. So, example 5, we're just going to visually mark up. We're not going to do a formal proof on. But let's do this together as the closing of this video. Oh, pardon the interruption. Internet friends, it's too late for you, but there's a girls' ice hockey game. All right, track this logic, friends. AC is congruent to itself. Why? Reflexive. All right, watch this. AB is parallel to CD because these 2 angles are congruent. Those are alternate interior angles, so by the alternate interior angles converse, stop packing up, track this. Those are parallel. Does that help me find this angle? No, it doesn't. Actually, I didn't even need the parallel. Check this. I know that angle D is congruent to angle B by the third angles theorem, and then I know that both triangles are congruent to each other because corresponding parts of congruent figures are congruent. All right. Yeah, reflexive was the AC to the AC. Well, thanks for watching, Internet friends. Have a great day.